In 1984, astronaut Rakesh Sharma looked from orbit and described the Indian subcontinent as a single cohesive shape, distinct from the rest of the planet. But that uniformity is an optical illusion. If you bring the camera closer, that single shape fractures into extreme, contradictory environments. Frozen mountain peaks, barren landscapes that look like the surface of the moon, blistering sand dunes, and massive, lush flatlands. Understanding the region's mechanics requires looking past the flat surface to its verticality. We are going to follow the path of gravity. By tracing the landscape from the absolute roof of the country down to its most ancient bedrock, we can see exactly how this geographical engine dictates the lives of over 1 billion people. About 50 million years ago, the landmass that is now India migrated north and crashed into Eurasia. The sheer force of that impact pushed the Earth straight up into the sky, creating the Himalayas, the tallest mountain range on the planet. You can still see the physical evidence of this violent compression today in the massive folded rock layers found across the region. This collision is still happening. The Indian landmass is constantly pushing northward, driving the mountains roughly 5 millimeters higher every year. This crash also created a geographical anomaly. Ladakh. Because this terrain was folded up from the space between the colliding plates, it is a chunk of ancient ocean floor pushed thousands of meters into the sky. The result is a high-altitude cold desert, where winter temperatures drop below -30 degrees Celsius. Wind has eroded the rock into a landscape that closely resembles the surface of the moon. These towering extremes form the roof of the subcontinent, capturing and hoarding the region's most critical resource: frozen water. When summer temperatures rise, that hoarded ice begins to melt. We can follow gravity downward from massive high-altitude glaciers like Gaumuk. The meltwater feeds into major river systems like the Ganga and the Brahmaputra. These rivers act as a massive circulatory system, grinding away at the rock and dragging rich, pulverized minerals down from the high peaks. As the water reaches lower elevations, it slows down and deposits those minerals, transforming the flatlands into the incredibly fertile Gangetic plains. This specific feature acts as the agricultural breadbasket of India, providing the resources necessary to support hundreds of millions of people and ancient civilizations. Gravity is the engine here. It pulls the potential of the frozen mountains down into the flatlands, turning it into the lifeblood of the entire region. If we shift our focus westward, we can see what happens to the land where the mountain water stops flowing: the Great Thar Desert. It is a harsh region of blistering heat and freezing nights. Survival here requires extreme adaptations, like scouring dishes with dry sand to conserve every possible drop of water. This desert presents a physical threat. Prevailing winds push these massive sand dunes eastward, and without a barrier, they would eventually swallow the fertile agricultural plains. The region is protected by the Aravalli Hills. At roughly 2.5 billion years old, these mountains predate the tectonic collision of the Himalayas by a massive margin. These hills act as a physical wall. When winds carry sand from the west, they hit the Aravalli Range, forcing the sand to drop and preserving the green, fertile plains on the eastern side. By holding the desert at bay, these ancient hills preserve the delicate balance of the entire subcontinent. Descending into the southern half of the country, the landscape transitions into the massive Deccan Plateau. This is the original landmass that survived the tectonic journey and collision, acting as the bedrock foundation of the country. The plateau is bordered along the coast by the Western Ghats. Their elevation tilts the entire plateau eastward, forcing major rivers to drain across the country into the Bay of Bengal. This topography creates a protected haven. The landscape supports dense forests, ancient tribal cultures, and a distinct biodiversity found nowhere else. This ancient foundation anchors India, creating a self-contained ecosystem shielded by its coastal mountains. Viewed through a topographic lens, the subcontinent reveals its true nature as an interconnected, three-dimensional survival machine. The mountains are its water towers, the rivers are a circulatory system, and the hills are its shields. Geography operates as the master script of the subcontinent, continuously dictating